Hi everyone, we're going to talk about the mole concepts today. Before we go to the mole concept, it is necessary to understand about the periodic table. So very easy, only two information we need from the periodic table for to cover this mole concept. The first thing, we just look at what are these groups and what are these periods. So groups are the columns on the periodic table and the periods are the horizontal lines. So we put this one to the next stage and we talk about what we need, what information we need today. So for example, for element we represent E. Normally on the this side of the element we have mass number, and this side you got atomic number. So likewise, for example, if you get beryllium has 9.012. So 9.012 is the atomic mass and 4 is the atomic number. This two information you need for cover uh, the mole concept. So I describe a little bit. So for example, this first two called S block, S block, and this part called P block, and this part over here 21 to 30 D block, and also over here we have F block. So in this course we're talking about the S block, P block and D block in later on, and F block we don't talk about. Okay, let's move into the other slide. So important of mole concept. What is the important? So mole is a way of counting. So 1 dozen of apple is 12 apples, and 1 ream of paper means 500 sheets. Likewise, 1 mole means 6.23 10 to 23. That's just a number. So if you got mole here, mole is 6.023 10 to 23. So for example, if you got 1 mole, it is 6.22 10 to 23. 2 mole, 6.023 to 10 to 23 times 2. 3 mole means 6.022 10 to 23 times 3. 4 mole equal 6.022 times 10 to 23 times 4. You can see now the number of 4 moles mean 4 times Avogadro constant. So this number also called Avogadro constant. Okay. So there are one basic equation to we have to use it in this case, but out of that we can get another two more examples to example equation. So first equation is simple n equal simple m over capital M. Okay, so simple n equal simple m over capital M. Out of that we can get, for example, there's a 1 always here, so you crisscross like this, and then simple m become simple n times capital M. So this is the second equation. Okay, and out of this we can get simple n equal simple m capital M equal, give me a second, capital M equal simple m over simple n. So this is the third equation. So this is first equation is this one. It is simple n equal simple m over capital M. Second one simple m mass equal ones. So simple N here is number of moles. Simple M, the normal mass. Capital M, atomic mass. Okay, let's go into the problems. Okay, so the problem they're asking, a chemist has a jar containing 388.2 gram of iron fillings. How many moles of iron does the jar contains? Okay, so now we're doing this question. Okay, it's asking how many moles. So how many moles means in this equation, this one, how many moles? So it given simple M, simple N, so we don't know it. Simple M as 388.2 gram, and atomic mass for iron is, so we go to the periodic table, this iron here, it says 55.85. okay, 55.85, 55.85. So now N equal M over M. M is 388.2 divided by 55.85. Let's calculate it. To the calculator, 388.2 divided by 55.85, 6.95. It comes in 6.95 mole of iron. So this is the answer. Okay, second question. It has given simple M. Simple M equal 28.1 gram. And also it's saying silicon. So M silicon. Atomic mass of silicon is how much? 28.080. Where the silicon? Here. Silicon is here. So you can get the number out of that. It is 28.08. 28.08. So now they are asking how many moles here. See here number. How many moles? Is N equal M over capital M. Simple M is 300. 28. Sorry. 28.1 divided by 28.08, nearly one more. Yeah, okay, in this one done, and we talk about this one now. Okay, this as before, simple M is, so simple M equilibrium, simple M or capital M, simple M is 0.255 divided by M for sulfur. You go to sulfur here, so sulfur is 32.066, 30.066. So into the calculator, 0.255 32.066, 30.066, 7.9 10 to 3, 7.9 10 to 3. This is the answer. So this should be 10 to 3. Okay, that's that question. So we move into the further. So calculate the mass of each of the following. Then now they're asking mass. So we focus on this formula. Simple M equals simple N or capital M. Okay. So now first question. Number of moles given 1.22, and also sodium. It is given sodium. So sodium more atomic mass is we had to find out from here. Sodium is here. Sodium is here. The sodium is actually 22.990. 22.990. So now we have to get simple m. Simple m equal simple n over times capital M. Simple n 1.22, capital M 22.99. So into the calculator, 1.22 times 22.95 is coming 27.9. 27.99 equal 28 grams. Okay, now this one over here pretty much in now simple everything. Simple m equals capital M. Simple n is 14.5. Capital M of copper. Copper is over here. Copper is over here. This is the molar mass. Sorry, atomic mass. Atomic mass of copper is 63.54. 63.54. That came from here. Copper. And times into the calculator, 14.5 times 63.54, 921 gram. Okay, that's right. Okay, let's move into the other one. Okay, calculate the amount of moles in each of the following quantities. So now they're asking amount of moles. So 1 mole is always 1 mole, like I said before. 1 mole is 6.022 10 to 23. So if we got this much atoms, 10 to 23, how many of these in here to get, we have divided by the Avogadro constant? Yeah, you got it? So you have to find out the amount of moles. 1 mole is this, so divided by this one. So same way, like if we have 24 mangoes, if you want to get the how many dozens in there, you have divided by 12. Yep. So then it give you 2 dozens. So same way, if you given a number, if you want to find out how many moles, you divided this number by mole to give you how many moles. So in this case, 10 to 20, 10 to 20 cancel out, nearly 0.5 atoms. Oh, sorry, 0.5 moles. Mole of what is the element? Rubidium. So 0.5 mole of rubidium here, or half Avogadro constant of rubidium moles. Okay, that's done. Second one, same way, just look at here is 22, 23 powers. Okay, so now here again the same thing, we have to find out number of mole. What do you do? Same thing like before, 8.08 10 to 22 divided by Avogadro, 6.022 10 to 23. So once you divide this by this, you can do this way, 80.8 times 10 to 23 divided don't worry about that. So what happened here? Yeah, we could put this straight here to the computer, to the calculator. 8.0208 times 10 to 22 divided by 6.022 10 to 23. 0.134. 0.134. It's coming 0.134 mole of krypton. Krypton is a noble gas. Clear? Let's move into the other question. This time they have given this time they given the mass. They are asking number of atoms. So first thing we need to find out the moles. So first step, simple n equal simple m over capital M, simple M 54, and aluminium is here. Its molar mass is 26.98. 26.98. So into the calculator, 54 divided by 626.98 is 2. So now they are asking calculate the number of atoms. So we have 2 moles. So number of atom equal 2 mole. So 2 mole means 2 times mole. The mole is 6.23 10 to 23. So 2 times 6.022 10 to 23. 2 moles. That's come 6.22 times 2, 1.224. 1.21 10 to 20 24 atoms of aluminiums. Yep. So you got how many moles? You got 2 moles. So 2 moles mean 2 times the mole. That's how we figure out. Okay, other question over here. First step, we do 69.45 divided by lanthanum. Lanthanum is La here. Lanthanum is here. It is 138.506. Going again to see these 138.906. 138.906. Okay, that's give number of moles. So 69.45 divided by 69.45 divided by 138.906. 138.906. It is coming 0.49. 0.499 moles. Now they are asking how many number of atoms. Therefore what we do, this is time here, 0.499 times this mole 6.22 10 to 23. So that means half of this number, because this is 0.5. So we have half this one. That's coming 311 10 to 23. Yeah, this is the answer, and this is the my answer is same. Okay, let's move into the other one. Okay, calculate the number of atoms in each of the following amounts. So this is the very easiest question. You don't need to know anything. You just need to know what is the mole or what is the Avogadro constant. So the first question, it asking 1.004 mole mean what? We know mole is Avogadro constant. So we write 1.004 times Avogadro 23. Let's see. Before, remember I told you 1 mole is 1 times Avogadro, 2 moles is 2 times Avogadro, 3 moles is 3 times Avogadro. Like 1.004 moles means 1.004 times Avogadro. So it is basically coming to 6.046 times 10 to 23. Okay, so we do this one, same thing, same way, 2.5 times 6.022 10 to 23. So now if you plug into the calculator, 6.022 times 2.5 become 15.055. 15.055 10 to 23 equals 1.5 10 to 24 atoms. Okay, you clear? That's it. Another one, stated problems. Calculate the mass of the following number of atoms. So now they are asking this one, this question here, this equation here. So it is simple m equals simple n capital M. Simple n is we have to find out. So simple n we don't know. Capital M of tantalum is 73, should be somewhere over here. Okay, this is the tantalum. That's got 180.998. 180.998. Simple n, how do you get the simple n? Simple n saman equal how many Avogadros of atoms. So simple n equals 6022 10 to 24 divided by Avogadro, 6.022 10 to 23. So you understand, they have given number of atoms like previous way. How many Avogadros are means how many moles. If they given a number of atoms, when you divide by the Avogadro, it's given number of moles. So straight away into the calculator we get 6.022 times 10 to 24 divided by 6.022 10 to 23 is coming 10. So 10 moles. 10 mole. So now we know simple n is 10 mole. So we can do calculation like this. Simple m equals simple n capital M. Simple m equal 10 times 180.99 equal 1810 gram of tantalum. You clear out that one, okay?